In this video we're going to consider prime numbers and how to find prime numbers. Okay, first of all, prime numbers, they are simply counting numbers like 1, 2, 3, 4, 5, so on and so forth. A prime number is a counting number that is only divisible by 1 and itself. Here I'll give you a couple of examples. One example of a prime number is the number 3. It is only divisible by 1 and itself, 3. Just like all numbers. All numbers are divisible by 1 in themselves, but if that's all that divides into that number, then that number is a prime number. Okay, then we look at the number 6. It's not a prime number. The number 6, I can write that as 1 times 6, just like all numbers can be written as 1 times themselves, but 6 can also be written as 2 times 3. That means that it is divisible by 2 and is divisible by 3. Therefore, 6 is not a prime number. Okay, how to find prime numbers? Well, an ancient method is called the SieveOfEratosthenes. I'm going to walk you through that in just a moment. But a sieve, I want you to think of just a strainer for your spaghetti. You pour the water in, and you pour the water and the spaghetti into the strainer. The water drains out, the spaghetti stays in. That's the idea with the SieveOfEratosthenes, is we're going to consider a bunch of numbers, 1 through 50, and we're going to eliminate all of the non-prime numbers and only have the prime numbers remain when we get done. Just like you pour the stuff into the strainer, the water pours out, the spaghetti stays in. Well, that's kind of what we're going to do with the SieveOfEratosthenes. Okay, to get started, we're going to consider the number 1. Well, the number 1, it's neither prime nor composite. Kind of like the number 0. The number 0 is not positive nor is it negative. It's just kind of neutral. Well, when it comes to prime and composite numbers, 1 is exactly the same, has exactly the same feature. It's not prime nor is it composite. It's just kind of neutral. Okay, then we're going to look at the number 2. The number 2 is the first number that we see that is only divisible by 1 and itself. Thus, it is the first prime number. So we're going to circle it. So I'm going to go back and forth between this page. Okay. Now we're going to scratch out all of the multiples of 2. For example, 2 times 2 is 4. We're going to scratch out 4 because 4 is divisible by 2. Now we start over. We start at the beginning. Now we're going to consider the number 3. Hey, it's the next number that's only divisible by 1 in itself. Thus, it's a prime number as well. But then we're going to scratch out all the multiples of 3. And this page. So it says that 2 is a prime number because it's only divisible by 1 in itself. So we're going to circle the number 2. So we're going to scratch out the number 4. And 2 times 3 is 6. So we're going to scratch out the number 6 because it's divisible by 2. And how about 2 times 4? Hey, that's 8. So we're going to scratch out the number 8. Now, if you can tell, basically we're going to scratch out all of the even numbers because all of those are divisible by 2. So if you'd follow along and do the same thing, you're going to be scratching out all of the even numbers except for 2 itself, because 2 is our first prime number. And all of these even numbers are multiples of 2, so they've got to go. And of course we circled 2 because it is a prime number. And I'm going to change color. And we're going to look at the number 3. It is a prime number, but all the multiples of 3. Well, there's 3 times 1, which is 3, but 3 times 2 is 6. And we notice it's already been scratched out because it's a multiple of 2 also. Okay, but then we've got 9. And 3 times 4 is 12. It's already been scratched. And 3 times 5 is 15. And 18, 21, 24, 27, 30, 33, 36, 39 is a multiple of 3, 42, 45 is a multiple of 3, and 48. and that's all the multiples of 3. Okay, so now we start over. Well, we've already scratched out the 4. Now we need to consider the 5. 5 is a prime number. It is only divisible by 1 in itself, so it's a prime number. But then all of the multiples of 5 have to go away. So that is 10, 15, 20, 25, 30, 35, 40, 45, and 50. Now we go back to the top and we look across our top row, and the next number that we come to is 7. And 7 is a prime number, and I'm going to do that in orange. Now we go through the multiples of 7. Well, 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. And then 42. And 49 gets scratched off because it's a multiple of 7. Okay, now we start over. And the next number that we come to is 11. Okay, 11 is a prime number. Now we scratch out the multiples of 11. Well, 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. And 44. And 11 times 5, of course, would be 55, but we're just concerned about the prime numbers that are less than 50. Okay? So, we start at the top again, and the next number that we come to that is either not prime or hasn't been scratched off yet is 13. And 13 is a prime number. So we scratch the multiples of 13. 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. And 13 times 4 would be 52, but that's larger than what we're concerned about. It's larger than 50, so we're not concerned about that anymore. Okay, so again, we start over. And let's see, I'm trying to pick a nice color here. That's kind of cool. Our next number that we need to consider is 17. 17 is a prime number, and that's 17 times 1. Well, 17 times 2 would be 34, and that's already been scratched off. And 17 times 3 is 51. We're not concerned about it either. Okay, so I'm about to run out of pretty colors, so let's go back to something different. Anyway, so our next one is 19. There it is. There's 19 times 1. 19 times 2 would be 38. It's already been scratched off. 19 times 3 is 57, but it's larger than 50. Okay, so let's see here. All the prime numbers less than 50 are, let me see, 23 is another one. The next multiple of 23 would be 46, but it's already gone. And then our next prime number is 29. And the next one is 31. And our next one is 37. And you know what? If you have these memorized, you'd be in good shape. Probably the best thing you could do is write in your notes. I mean, it'd be nice that you had this sieve here worked out so you could see where they come from, but you need to have these numbers memorized one way or the other. 2, 3, 5, 7, 11, 13, 17, 19, and 23. Ladies and gentlemen, if you have these numbers memorized, and as soon as you see them, you recognize that they are prime numbers, you're going to be in pretty good shape for doing what we have to do when it comes to multiples, greatest common factors, and then eventually fractions. Okay, thank you for watching.